This video, we are going to be tackling the valid palindrome LeetCode problem. And to kick things off, let's go ahead and read the description. A phrase is a palindrome if after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers. Given a string S, return true if it is a palindrome or false otherwise. This is a pretty easy question, but there's a lot of edge cases, so let's go ahead and jump into the first part of what is a palindrome. So a palindrome is a word where it is spelled the exact same if you turned all of the letters backwards. What do I mean by that? Let's kind of go into a little bit more depth. So if you drew an imaginary line in between the middle of the word, it would be the exact same. And these words are really rare. They're not that common. And noon is a good example. Civic is a good example. Kayak is a good example. If you literally reversed everything, it would be exactly the same. And we need to return true. There are many ways to solve this problem, and one of those ways is to use reverse methods. Reverse methods are going to drastically reduce how complicated the algorithm is and make it so that your algorithm could be just a couple lines of code. But the bad thing is that this is not going to be enough for Microsoft or Google, and they're going to want you to have a better space complexity, and reverse has a linear space complexity. But what we can use is what's called a two-pointer approach. And the two-pointer approach is better because it has a better space complexity, so it takes up less memory. Also, two-pointer is used everywhere in LeetCode, so it's also a great learning experience, and you can use these patterns that you're going to learn everywhere in LeetCode. So we're going to be solving this with the two-pointer approach. So we are in fact going to have to initialize two pointers, which we have right here. We're going to initialize one pointer in the very beginning and one pointer at the very end. There are different ways there are some situations where you can initialize pointer over here, but I choose to do it to iterate into the middle because I think it just makes more sense since this is a palindrome question. So what we will do in each iteration, and we're going to use a while loop. In each iteration, what we're going to do is we're going to check, are these two numbers the same? If these two numbers are the same, it is indeed going to indicate that it is partially a palindrome, but we need to check the rest of the numbers. So first thing, every single iteration, all that we're going to do is check if the two letters are the same for the pointer. And in our case, they are indeed. Next thing, we're going to increment this pointer right here. Always remember, if you have a problem like this, you want to increment instead of decrement. So we're going to increment this number and we're going to move it over just like this. And then we are going to decrement the number at the end. Remember, that is very important. Do not get those mixed up because it is very easy to. And then we're going to decrement this number right here. So go ahead and move that one over. Then we'll go ahead, check it same as we did before. Each iteration, we're just going to check if those two numbers are the same. And this process is going to repeat itself. The increment, we're going to increment this one, then we're going to decrement this one, as you probably guessed already. And we're going to keep doing this until we get to the middle where the loop is going to break because these two arrows are going to try to cross. The left arrow is going to be greater than the right arrow, and our logic is going to break within the while loop. And that's pretty much it. But once again, there are a lot of edge cases, but I'll walk you through those as we code it up in VS Code. Let's go ahead, hop over into VS Code and solve it. So we are inside of Visual Studio Code, and the first thing that I'm going to do is create a new class, and I'm going to call it solution. You don't have to do this. You could put this in the program.cs, but I'm going to go ahead and separate it out. And what I'm going to do is, first things first, I'm going to go ahead and create the method, and we can talk a little bit about how this is going to work. We are going to return a bool, and this is going to make our lives 100% easier. Just because we have to return a bool, this makes this question a lot simpler, easier to understand, and we're going to give it a method name of is palindrome, and you guessed it, we're taking in a string. So now we're going to initialize our two pointers. And when we initialize our 2 pointers, we're going to have a right and a left, and this right is going to be s.length -1. And the reason that we have the s.length -1 is because if we don't have the s-1, it will give us an index out of bounds. And the reason that we have the left 0 is because we want that first pointer at the very beginning of the array, and we want the other arrow at the very end of the array. Very simple. So next thing, and this is just for edge cases, a lot of this code that you may not, this code that may be confusing is because we have a lot of edge cases here. Because we don't have to worry about the capitalization, we're just going to go ahead and lowercase everything. And next thing that we're going to do is we're going to declare a while loop. Now, most of the time when you create actual two-pointer questions, or you're trying to solve two-pointer questions, you're going to be using a while loop. And all this while loop is going to do is detect when the 2 pointers try to cross each other. So if the 2 pointers try to cross each other, this is when the while loop is going to trigger and break. Next thing that we have to do is we have to iterate over actual non-alphanumeric characters. So let's just say here there's a space right here, or a hyphen. Here's a better example. Let's just say that there's a hyphen. The code that we're about to write is going to check to see if it's non-alphanumeric or not a digit, and it's going to go ahead and skip it. So if this code coming up is confusing to you, just remember it's there just to skip things that are non-alphanumeric. And we're going to say if left is less than right, and this is the part that's going to check to see if it's non-alphanumeric. If char, let's see here, char dot is digit is letter or digit like this, and we'll say s dot left, just like that. And then we're going to go down, and this is where we're going to left, we're going to increment it just like this. And then the same thing, we can actually just go down right here, and then we can go ahead and just do the same thing, but we can also do the right, and we can change this to the right here. Okay, looking great. Next thing, this is where things are actually going to look a little bit familiar. The code before is just to handle edge cases, but this code right here is going to be very familiar to what we were talking about earlier. And this is going to be where we check if the right pointer is equal to the left pointer. And if it is not, this is actually, we're checking to see if it is not right here, we're going to return false. And this is great because as soon as the actual, so let's just say if we're trying to check this one right here, and this is a T, as soon as it is not equal to this number on the, as soon as the left pointer is not equal to the right pointer, we can go ahead and break, and that will also greatly increase the speed as well too. So we're going to check to see if they are not the same, and if they are not, we're just going to go ahead, break it out, and it's going to be false. And then right after that, this is when we're going to increment, and this is when we're going to increment the left, and then we are going to decrement the right. And that is pretty much it. So we'll go down here. Let me make sure that my actual brackets here are aligned. So we go down here, and then right after the while loop, this is when we're going to return true. And that is pretty much it. So let's go ahead in here. I'm going to go ahead, copy all of this, and we are going to go ahead and paste this into LeetCode. I need to make sure that my brackets are good. So go ahead into here. Let's go ahead and get out LeetCode. And I'm going to go ahead and copy and paste this into here and check to see if our test cases run. And our test cases run. Let's go ahead and submit it, see what we got. Boom, we are looking good. And we are on the very left here, which is where we want to be. Let's go ahead and check the time complexity. Time complexity is linear, and we can also check the memory complexity. Look at that beautiful constant space complexity. Anyways, hope that you guys enjoyed this. If you did, make sure to smash that like button, smash that subscribe button, and as always, thank you for watching.